Okay, so here is a guide to the answers to the matching graphs and then the proportions. I know the proportions, you have the answers, but if you have any doubts as to how to get those answers, then I'll address them now. So let's jump right into number 4. The first three are already done. So number 4 is square root of p over r. So we have p on the x-axis, I on the y-axis, r stays constant. So I just go through the process. I is proportional to radical p based on that equation. Again, since I'm ignoring r, I don't have to worry about the dividing sign. So square root function looks like this. And if I want to linearize it, I actually have two options here. I'm going to guess you would have gone with i's and you put radical p there. And that's not wrong. That's fine. The alternative, which is actually preferred, is to square both sides and make this I squared and make this p. But either way, what I put in green, what I put in red are valid. All right, Pivnert, gas law, P and T. So we have a bunch of constants, so we just ignore them. So we see that P is here, T is here, so P is proportional to T. That's a linear, nothing else to do with that. All right, same equation. Now we're looking at P and V. All right, so this is a little bit trickier because they're on the same side of the equation. So what I do is I move, since P is my x variable, I'm going to move the P to the right side. So when you have your two variables on the same side of the equation, move 1 over. So if I move P to the other side, I see that V is proportional to 1 over P because I had to divide by P to keep that inequality. So if I do V versus P, that's an inverse. Okay, so to get a straight line, I do 1 over P to get the straight line. I guess I should keep doing these in green. Next one. So this looks like maybe an intimidating equation. I don't want it to be. We can keep it simple. So R is our x and F is our y. Little q and big Q are constants, so we ignore those. So we want you to recognize is the r squared is in the denominator. So we have F is proportional to 1 over r squared. So this throws kids off because they see that squared and they automatically assume quadratic, but it's not quite that because the r is in the denominator, right? 1 over it. A bigger r right here means a smaller f. The square just makes it get smaller quicker. So this is actually a form of inverse. So if I plot f versus r, I'm going to get a pretty steep inverse. It's technically called an inverse square, but you don't need to distinguish between, let's say, that and that. I mean, for all intents and purposes, they're the same shape. If I want to linearize it, then I do f, and what I have there is my proportionality, 1 over r squared, and I would get a straight line. Next one, same equation, but now we're keeping Q and R constant. So what I break this down to is I ignore the big Q and I ignore the R. Okay, what that leaves is F is proportional to little q. It's as simple as that because those are constants. So that's simply a straight line. And in the last equation, we want to look at T as a function of D, or D as a function of T, I should say. Ignore the half, we ignore the A, we see D is proportional to T squared. So if I plot D here, T there, that squared tells me I get a quadratic. And if I want a linear, D versus T squared, and that gives me a linear. Okay, so let's look at the proportions. I have the solution to the one that I did. So let me do the others. K is 1/2 mv squared. I'm keeping v constant in this one, so I ignore that. So basically I have k is proportional to m. So I could say k2 over k1 equals m2 over m1. Everything's to the first power. So you're told m is tripled, so that means m2 over m1 is 3 times as big as before. Therefore, k2 over k1 is 3 times as big. And that's my answer. Equation 3, which I believe is T is D divided by V. Okay, so V is doubled for a given D. By what factors T change? So I'm looking for T2 over T1. Now this might be a little bit confusing. There's another way of doing it. So let me just rewrite this equation. We're saying is t is proportional to 1 over v. That's what we established on the other side. So I got to keep that on here. So that becomes 1 over v2. Whoops, that shouldn't say v squared. It should say v2. Divided by 1 over v1. So that's a complex fraction. If I do copy, change, flip, that's really just the same as v1 over v2. Okay, now, here's where we got to be careful. And this says v, actually, no, I'm not going to do that yet. That's probably going to confuse you. So I'm going to put in what I know. Okay, v is doubled. So if v is doubled, that means v2 is twice as much. So I'm going to put in 1 over half for the double part for v2 versus 1 over 1. Okay, this value is double this value. That's what you're told. So what's 1/2 divided by 1? It's 1/2. So in other words, doubling v gives me 1/2 t. Well, that's the hallmark of a inverse equation. If what I just did here confuses you, then come up with an alternative method. The alternative method that I originally started, that I changed my mind because I thought maybe it would be confusing, is I can simplify this part on the right and call that v1 over v2. So if v2 is double v1, because that's what's given, then I just put 1/2. Okay, in other words, I put a double the value of this up here. Either way, I should get 1/2. All right, same equation. V is halved for a given d. So I'm really doing the same proportion. I want t2 over t1, and I'm going to go with this one right here. I already know that's v1 over v2. So what's going on? v2 is half of v1. So what's 1 divided by half? Double. So I get the reciprocal of the answer above, which makes sense. Here we doubled it and got half the time. Here we have the v and we got double the time. So I want you to understand that connection. All right, two more, I believe. Oops, I guess I missed one on here. Okay, so we had the equation I equals radical p over r. So we know r is the same here. I is proportional to radical p. So what I would say is I2 over I1, that's what I want, equals square root p2 over p1. Okay, so I keep the radical sign from right here and then put my proportionality. Well, p is quadrupled, so that means p2 over p1 is 4. So it's a square root of 4, which is 2. So my new I is going to be twice the old I, or the ratio is 2 to 1. Let's continue on. I had to write in the next one. So we're going to equation 6, which is F equals QQ over R squared. And so we're going to change R for a given Q and little q. So this equation becomes F is proportional to 1 over R squared. There should be a squared here. Okay, so this is, again, algebraic, a little bit tricky, but recognize we're looking for F2 over F1. I want to know how F changes. So that's going to become 1 over R2 squared over 1 over R1 squared. Again, because the R is the denominator, I got to keep that in my proportionality. That simply becomes R1 squared divided by R2 squared. Well, I'm going to change that to R1 over R2 whole quantity squared. That just makes it easier. Okay, now we can put in what was changed. What was changed is R is doubled. Okay, R2 is double R1. Okay, so this becomes, in the parentheses here, parentheses, R1 is the original, so it stays 1. R2 is doubled, 2. And then I just got to square the whole thing. And so it's 1/4. So, again, conceptualize this. R in the denominator means the bigger value of R, the smaller value of F. So if I make R bigger, I'm going to get smaller F, hence a fraction. Doubling R, you might think gives us 1/2 of F because of the squared. It's really just 1 over 2 squared. Our last one, I might have mixed little q and big Q, but it won't change the answer. So same equation, but now since R is staying the same, I'm just going to do F is proportional to Q times big Q. Okay, I keep what was on in the numerator because both are changing. So F2 over F1, I'm still looking for that, is basically equal to Q2 over Q1 times big Q2 over big Q1. I just do a separate one for each variable. So little q is triple, so the first parentheses is 3. The big Q is doubled, so that's just 2. So I get 6. So by changing both of these, I increase F accordingly. And that's why I get a 6-fold increase in force. So as always, ask questions if I did something you didn't quite understand.